Let's see these examples. I given some examples just to make you understand what is linearly dependent and what is linearly independent. Okay. So see this. Show that the vectors x1 equal to 1, 2, 4 and x2 equal to 3, 6, 12 are linearly dependent. So what do you mean by linearly dependent? I should be able to write them in a form of k1 into x1 plus k2 into x2 equal to 0. Now just by quick inspection you can understand that if I multiply the first one with 3, x1 with 3, I get x2, isn't it? Multiply x1 with 3, you'll definitely get x2. Therefore I'm directly writing it this way. How am I able to do that? Just by inspection. So there is other method to solving it, but then this one is too trivial to apply big methods. That is why I'm just inspecting it and applying it. See this. Therefore 3 into x1 equal to x2. So how can I put this in other way? 3 into x1 minus x minus 1 into x2 equal to 0. Therefore I am able to write these vectors in a form of k1 into x1 plus k2 into x2 equal to 0, where k1 and k2 are not simultaneously zeros. Okay. Next one is show that the set containing only of the 0 vector 0 is linearly dependent. So if you have only one vector which is completely 0, right, then we have to show that it is linearly dependent. So if you have only one vector which is 0, of course we can multiply with, let us call that vector 0 vector as x. You can multiply it with any constant. Here in this case I am multiplying it with 1, still I am going to get 0. Therefore we are able to find out a constant and we are able to put it in the form of k into x1 equal to 0. Therefore it is linearly dependent. It is just trivial small example. This is interesting. See this. Now we have to find out whether these two vectors are linearly dependent or linearly independent. So if you observe them, you cannot directly inspect and say that this is a multiplication of that. So let's go with the procedure. So the procedure is, let us assume that these two are linearly dependent. So what happens if they would have been linearly dependent? We would have been able to write them in the form of k1 into x1 plus k2 into x2, right? So x1 is this, x2 is this. So since I am assuming that they must be linearly dependent, I should be able to write them in the form of k1 into x1 plus k2 into x2 equal to 0. k1 into x1 plus k2 into x2 equal to 0. I should be able to write it. Then I am assuming that this is possible. That is just my assumption. Then I am just expanding. I am just substituting in place of x1 and x2 here. Now if you observe it, k1 into 1 plus k2 into 4 is equal to 0. I am just equating them element to element. Okay. k1 into 1 plus k2 into 4 equal to 0. k1 plus 4k2 equal to 0. And similarly k1 into 2 plus k2 into minus 2 equal to 0. 2k1 minus 2k2 equal to 0. So if I keep writing like that, I got these three equations: equation 1, equation 2 and equation 3. Now if you try to solve them by taking any two equations, and whatever result you get, if you try to put it in the third equation, that might not agree. So what happens is, here if you try to solve them by taking these two equations for k1 and k2, and whatever result you get, if you try to put it in the third equation, that will not agree, which means there will not be any set of k1 and k2 which will be able to satisfy all these three equations simultaneously, except only one value, which is k1 and k2 are zeros. We already know that if you are able to write this form, and then if you are able to find out that this form is true, only when k1 and k2 are zeros, then such a pair of vectors, we already know that they are linearly independent, right? So they are linearly independent. This example is linearly independent. I hope you understood the concept. So what I am trying to say is, I assume that they are linearly dependent, which means you should be able to find out k1 and k2 in such a way that both are not equal to zeros, right? But then here I am able to get in this form only when they are equal to zeros. Therefore they are linearly independent. Now what is this one? x1 equal to 1 0 0, x2 equal to 0 1 0, x3 equal to 0 0 1. So this is important and interesting for many reasons. One reason is, if you put x1, x2, x3 in form of a matrix, then it is nothing but identity matrix or unit matrix. Observe that. If you put x1, x2, x3 in form of a matrix, it is a unit matrix, right? And we know that the rank of a unit matrix is 3. It forms a 3 by 3 matrix, and the rank of it is 3, and therefore the number of linearly dependent vectors will be equal to size of the matrix n minus r. Okay, we shall see that later, which means in this case we are not able, there should not be any linearly dependent vectors. That is what I mean to say. Okay, so anyway, we shall see that later, the other way of solving it. For now, we shall see the standard way of solving it. What is it? I'll assume that all these three vectors are linearly dependent. Then I should be able to write them in the form of k1 into x1 plus k2 into x2 plus k3 into x3 equal to 0. Right? So that is what I am doing here. k1 into x1 plus k2 into x2 plus k3 into x3 equal to 0. Then if I multiply them, I am going to get this. So if I solve it, I am going to get k1, k2, k3 equal to 0. Obviously, all these three happen to be 0, and this is the only way we can satisfy these equations, isn't it? Therefore, we are able to get this equation only under the condition that k1 equal to k2 equal to k3 equal to 0. And what can we say? That they are linearly independent. Got it? So what is the advantage of all this is, I'll tell you the points. While solving the linear equations, finding out the number of linearly independent equations is important there. I'll solve that, okay? With examples it will be clear. Don't worry, don't get confused now. Why am I doing it all? It will all make sense by the end of this topic, okay?
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.